Which mathematician, would you say, has had the greatest impact on physics and the applied sciences? Going to go against the very obvious choice of Isaac Newton here. He was a natural philosopher first and a mathematician second, and to my best understanding his goal in mathematical innovation, e.g. calculus, was to understand the physical world and not math for its own sake. If the question had been, what physical scientist had the most impact on math, it would be him by a mile. I think the best answer is probably Euler. Hard to imagine, LOL, doing physics without the exponential function, imaginary numbers, complex analysis or topology. And those discoveries were not initially motivated by the sciences. In terms of more modern thinkers, you could make good cases for Hilbert and Turing, for sure. Von Neumann as well. Archimedes, and it's not even close. The sheer range and quality of his work alone is impressive, but he becomes the clear winner when you consider the relative poverty of mathematics and physical science in the age in which he lived. He was using infinitesimals and the method of exhaustion 1800 years before Newton and Leibniz. He didn't have Arabic numerals, he didn't even have paper. Yet he discovered and quantitatively described concepts like buoyancy, center of gravity, levers, general formulas for areas and volumes of spheroids and cuboids, including the formula for the circle. He all but invented scientific notation for large numbers. It truly boggles the mind how he was able to do so much with so little. He might have been the most gifted scientist humanity has ever produced. George Simmons said it best, if we consider what all other men accomplished in mathematics and physics, on every continent and in every civilization, from the beginning of time down to the 17th century in Western Europe, the achievements of Archimedes outweighs it all. He was a great civilization all by himself. If we are talking modern physics, Emmy Noether has to be in the running, but so much math flowed from Isaac Newton that he's the objectively correct answer unless you are using some kind of criteria that excludes him and the people immediately building on his work as they fleshed out and tried to understand his theories. A divergent opinion here, possibly the last scientist, who was universally well-versed and made seminal contributions to all branches of physics. His work had a huge impact across the whole range of physics and applied sciences. Although normally considered to be just a physicist, Landor was also an applied mathematician of the highest order. His first paper, for example, was on the derivation of the Klein-Fock equation. His accomplishments include the discovery of the density matrix method in quantum mechanics, the quantum mechanical theory of diamagnetism, the theory of superfluidity, the theory of second-order phase transitions, invention of order parameter technique, the Ginzburg-Landor theory of superconductivity, the theory of Fermi-liquids, the explanation of Landor damping in plasma physics, the Landor pole in quantum electrodynamics, and Landor's equations for S-matrix singularities. He received the 1962 Nobel Prize in Physics for his development of a mathematical theory of superfluidity. Beyond these accomplishments, he wrote the 10 Course of Theoretical Physics textbooks, including mechanics, fluid mechanics, statistical physics, electrodynamics. If we count people who made advances in both fields, then Newton is the right choice. Newton's innovations in physics were huge. Plus, his work on calculus, alongside Leibniz, is hugely important in physics too. Newton is also a popular answer because much of the physics he influenced is taught in high school and intro-level college courses. On the other hand, if the question is about people who were mathematicians only and their math work influenced physics, the answer is definitely Emmy Noether. Her influence on physics is somewhat more subtle. Some of it is a little bit obvious, spatial or temporal symmetries leading to momentum, energy conservation, but the role of symmetries in particle theory cannot be overstated. I do not think we could have constructed the standard model of particle physics without her work. This topic is usually reserved for courses in upper-level bachelors in physics, and even then the role of symmetries often does not fully present itself until physics graduate school, because it is rather less accessible than things like Newton's second law. But the performance of the standard model of particle physics, based on ideas from Noether along with many physicists, is so shockingly good.
Don't forget to like and subscribe so you don't miss our next exciting video.